All right, so today in class, the students on campus are doing some enrichment. And here are the problems that we're doing. We are doing enrichment on isomers. So here on campus during lecture time, we were working on these problems. And so if you're watching this video online, what I recommend you do is you pause the recording, try these problems on your own, and then hit resume when you're ready. You can also go to the course website and download this file. It's a PDF file. You can try it for yourself and then look at the answer key. So in the first problem, we're asked to determine the relationship between each pair. Are they the same molecule? Are they structural isomers, or are they unrelated? And if this were a test, it would also say justify your answer, because I wouldn't just expect you to say one word and call it good. So on a test, I would expect you to justify that. So there are the first two. And then here's the next two. I should say next four. And then there's the last one. Oh, kick this one onto the following page, shouldn't it? And there's one more. Okay. In the next two problems, I asked draw two cyclic pentanes with at least one substituent each. That would be classified as structural isomers, and we're excluding cis-trans because that's just too easy. And then in number 3, draw two cyclic octanes with at least one substituent each. That would be classified as unrelated. And then in the last problem, determine if the following are named correctly. If their names are incorrect, state what mistakes were made, and then provide the correct name. So there are the first 3, 1,5-dibromocyclohexane, 1-ethyl 3-chlorocycloheptane, dimethylcyclopentane, and the last one, 1-methyl 2-propyl-cyclooctane. So again, if you are an online student, I would recommend either going to the course website and downloading this file and trying it for yourself before watching this video, or if you're just watching this video online without the PDF, you can pause the recording, try it for yourself, and then resume when you're ready. So now we're going to go over these problems and see what we got. All right, in number 1, first one, we need to determine, are they the same molecule, are they structural isomers, or are they unrelated? And so for them to be the same molecule, they have to have the same formula and the same name, right? For them to be structural isomers, they have to have same formula, different names, and unrelated, they would have different formulas altogether, right? Different numbers of carbons, different numbers of hydrogens, everything would be different. So let's go through this. We've got 6 carbons here, 7, 8, so that's C8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, H16. Whereas this one here are 6 carbons, 7, 8, 9. Right, so we already know our answer, but if we were being asked this on a test, we would need to justify it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So one has the formula C9H18, one has the formula C8H16. I mean, just by looking at them, you can tell that these have different chemical formulas. So by that definition, what are they? They have to be unrelated, right? And just for good practice, let's name these. Where's carbon number 1 here? Is it the one with the ethyl or the methyl? It's the ethyl, right? So 1. And then am I numbering clockwise or counterclockwise? Counterclockwise. So just for practice, we've already determined they're unrelated, right? This would be 1-ethyl 3-methyl cyclohexane. And then here, it doesn't matter which one you pick as carbon number 1, as long as you number the correct way, right? If we pick this one, we're going to number clockwise. If we pick this as carbon number, we're going to number counterclockwise. So long as you have them as 1, 2 and not 1, 5, this would be 1,2-dimethyl cyclohexane. Right, so as our justification for this, we would say they have different formulas, therefore cannot be related. Right? They don't have the same formula, then there's no relationship whatsoever. Any questions on this first pair? That was pretty easy. I mean, you could just look at that, I think, and determine. All right, number 2. We're going to have to do some counting here with the cursor out of the way. All right, let's see. Let's first just identify the longest parent chain, because that'll help us in coming up with a name. Let's see, so if we count 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. That's not going to make a difference. 1, 2, 3, 4, 5. So this is going to be a hexane, right? We're going to start counting from number here, over here. So 1, 2, 3, 4. Now, does it matter which way we go? No. 5, 6. Let's go ahead and give it a name, just for fun. All right. We've got chloro, ethyl, ethyl, methyl, right? Do we agree? So this is going to be 2 chloro, then let's see, 3, 4 diethyl, 3 methyl hexane. And now let's come up with its formula. Let's see, 1, 2, 3, 4, 5, 6, 7, well, there's 6, 7, 8, 9, 10, 11. So this is C11. Now let's count our hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 2, 3. H23. And then that chlorine, we can't forget about it. All right, now let's slide over to our other contender. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. So it's going to be a heptane. Right? And so 1, 2, 3, 4, 5, 6, 7. Let's name it. Let's see, this is going to be 3 chloro, what? 4 ethyl, 3 methyl heptane. Right? And now let's come up with its formula. There are 7, 8, 9, 10. C10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. H21, Cl. So they look similar, but are these molecules actually related in any way? Nope, these would also be unrelated. And for the same justification as the previous one, right? Different formulas can't be related. But if you just glance at them, you say, we got a whole bunch of branching going on, we got a chlorine atom in there, maybe they're the same, right? But we actually have to go through, count our carbons, and then it's just good practice to also give it a name. But if one's a 10 carbon chain, if one's a 10 carbon molecule and one's an 11 carbon molecule, they can't be related. So you can't just go by looks, right? You have to actually go through the whole process. Any questions on 1 or 2? Well, I should say first pair or the second pair. Good? All right. Let's go to the second pair. Okay. What's the name of this molecule? It's cis, yes, because they're the same side. And then where's carbon number 1? Here, here. Up top or on the bottom? Top, and we're counting clockwise or counterclockwise? Right, 1, 2, 3, 4. So this is cis, 1, what? Ethyl, 4, what? Methyl, cycloheptane. And what's the name of this one? 1, 2, 3, 4. Right. So what's the diagnosis here? They're the same molecule. Right? They have the same formula and the same name. That one was a lot less work, wasn't it? Okay, let's look at our next pair. Let's see, we got to do some counting. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we've got 2 directions we could go. So how do we pick the correct one? We pick the one that gives us the most substituents or the fewest substituents? The most. All right, so if we go 1, 2, 3, 4, 5, 6, 7, 8, 9. So that gives us 1, 2, 3 substituents. If we go 1, 2, 3, 4, 5, 6, 7, 8, 9, that gives us 1, 2, 3, 4, 5 substituents. Obviously, we're going to go this direction. And actually, this is going to be carbon number 1, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, let's name it. I'm trying to stand in a place where I won't block the projector. Let's see, we've got ethyl, methyl, methyl, bromo. So bromo comes first, right? 5 bromo, then what? 3 ethyl, then what? 2, 2, 6 trimethyl, and this is a 9 carbon chain, no name. What's his name? And let's count our carbons. There are 9, 10, 11, 12, 13, 14. So C14. And now let's count our hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 5, 6, 7, 8, 29. H29, and then can't forget that BR. Okay, now let's do this one. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's not going to make a difference which direction I go because it's going to give me a 1, 2, 3 carbon chain or a 1, 2, 3 carbon chain. So we can go either way we want. So let's just keep it linear. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's name this. We have a bromo. So let's do 3 bromo. Then what do we have? 2, 2, 4, what? Trimethyl. Then what?
6 propyl.
Yep, 6 propyl nonane. So a lot of students would give them names and say, hey, they're both nonanes. Must be structural isomers. But what's the last piece of the puzzle we have to consider? You have to have the same formula to be structural isomers, right? So we can't just look at the fact that they're both nonanes, we have to count our carbons. So there are 9, 10, 11, 12, 13, 14, 15. Right? 9, 10, 11, 12, 13, 14, 15. Yep. 15 carbons, hydrogens, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. H31, BR. So what's the relationship here? They're unrelated, right? Right? Even though they're both no names, different formula equals unrelated. Can't be related if you don't have the same formula. So again, I caution against just going off the name, right? Because even if they're both no names, that doesn't guarantee that they are structural isomers. Any questions on these two pairs before we erase? Okay. All right, let's scroll down again. Last two pairs. There we go. Trying to get that knot on the seam of the board. Okay, I think this one's going to be pretty easy to diagnose without even doing much counting. What's the relationship here? We don't even have to do much detective work. There's no relation. They're unrelated. Right? Why are they unrelated? They have different formulas. Right? This is they're 6, 7, they're 5, 6. So that's pretty obvious. Right? That one's really easy. Last pair we need to look at. Let's figure out our carbons. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. So we're going to go this direction. Now we can pick either one of these as carbon number 1. 1, 2, 3, 4, 5, 6, 7. Nothing crazy going on in terms of substituents. This is just what? 2, 3, 4, what?
Tetramethyl.
Right, tetramethyl, what? Heptane. And it has the formula, let's see, there are 7 carbons, 8, 9, 10, 11, C11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 24, H24. And now let's do this one. 1, 2, 3, 4, 5, 6, 7. That gets us to our first substituent over here, fastest. Okay, so the name of this one is going to be
2, 3, 5, 5 tetramethyl.
All right, 2, 3, 5, 5 tetramethyl heptane. So they're both heptanes. Let's count our carbons. There are 7, 8, 9, 10, 11. So C11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, H24. So then what would the relationship between these two be? Right, these are structural isomers. And what's the reasoning or the justification? They have the same formula, but different IUPAC name, right? One of them is 2355, one of them is 2344. Questions on these two pairs? All right, let's go on to the next part of this enrichment. Draw two cyclic pentanes with at least one substituent each that would be classified as structural isomers of each other. We're excluding cis trans. Okay, because if you draw one with a wedge coming out, one of them dashed, that's too easy. Okay, so they're structural isomers. So what are the criteria? Your answers are going to be all over the place, or I pass this on a test. So if I'm grading this, what am I looking for? They need to have what? Same formula, right? But different names. So pentane, cyclic. With at least one substituent, so we can make this as difficult or as easy as we want. If you drew, let's say, this, is that enough to distinguish them as structural isomers? No, you need a second substituent, right? Because right now they're both called what? Bromocyclopentane, bromocyclopentane. So we need to have a second substituent. So what could we do to make a second substituent? Okay, so if you put a methyl group here and a methyl group here, would that make them structural isomers? Yeah, because this one would be 1, 2, this one would be 1, 3. So you can make these as difficult or as easy as you want, right? As long as you follow the rule that they must have the same formula and different names. Right, this one would be 1 bromo, 2 methyl cyclopentane. And this would be 1 bromo, 3 methyl cyclopentane. Right, those would be structural isomers. So again, you can make yours as difficult or as easy as you want as long as you follow that criteria. All right, let's look at the next pair. Two cyclic octanes with at least one substituent each, that would be classified as unrelated. For them to be classified as unrelated, what must be the case? They have to have different formulas. Right? Still both be octanes though. So we got to draw 2 stop signs. With at least one substituent each. And that would be classified as unrelated. So you can make this as easy or as difficult as you wanted, right? What did you do?
I put a methyl on one and an ethyl on the other.
Okay, a methyl on one and an ethyl on the other. That'd work. Yep, that'd work. I mean, you can, the sky's the limit here, right? Because this is going to have more, I mean, this one's going to have more carbons than this one. Even if you wanted to make it real simple, what if you made this a chloro and not a methyl? Right? That's following the criteria. So you can make this as difficult or as easy as you want. As long as they have different formulas, they're both cyclic octanes, they both have at least one substituent, you make it as hard or as easy as you want. Okay. For the next, we're deciding if they were named correctly. If the names are incorrect, what mistake did the student make? And then fix it. So first thing we do is we draw it as written, and then name it, and then see if the name that we came up with matches the name that we were given. So cyclohexane would be a 6-membered ring. 1, 5, 1, 2, 3, 4, 5. Is that the correct name for this molecule?
No.
No, that's incorrect. What was the mistake?
They numbered the wrong one.
Right. Numbered, wrong direction. What's the correct name?
1, 3,
Right, it should be 1, 3. Neither one of these could be number 1. If you pick this one, you go counterclockwise. If you pick this one, you go clockwise, right? 1, 3, diromo. Right, so that shouldn't be 1, 5. It should be 1, 3. All right, let's do part B. Heptane. Boy, cyclic heptanes are hard to draw because that's 7. That's a funky number. 1, 2, 3, 4, 5, 6, 7. I stink at drawing heptanes. Okay, so 1 ethyl, 1, 2, 3 chloro. Is that the name for this molecule? Nope, that's incorrect. What did the student do wrong?
It's not alphabetical.
Right, carbon number 1 is misidentified. Right? It should be alphabetical in cyclics. So carbon number 1 should be the chloro, right? 1, 2, 3. So it should be 1 chloro, 3 ethyl, cycloheptane. They just picked the wrong carbon number 1. All right. Part B is something I see a lot. Of part C. Dimethylcyclopentane. Is that name correct? No. Why is that incorrect? This is a really common mistake. Right. This name is way too ambiguous. Right, because to have a cyclopentane with 2 methyl groups, I could have 1, 1, right? But I could also have what? 1, 2, right? Or I could have 1, 3, right? Calling it dimethylcyclopentane is too ambiguous. And so you need to state the locations of the methyl groups. If it was just methylcyclopentane, would that be okay? Right, it would be okay, because if there's only one substituent, the 1 isn't needed. But if there's more than one substituent, you've got to tell me where the substituents are found. And then last one, that's a cyclooctane. One methyl, 2 propyl. Is that name correct? Yes, name is correct. Feeling good about this? All right. So that's where we're going to stop for today.